This video is to help introduce you to the unit circle and show you how to determine the unit circle without having to memorize a whole bunch. So let's go back to your college algebra times where you developed the equation for a circle as x minus h squared plus y minus k squared equal to the radius squared. So what this equation is saying is that there are a bunch of points, so all the coordinates x, y, that are a distance of r away from the center hk. Okay, so the center of the circle is at hk, the radius is r, and we're saying these are a whole bunch of points, all these x, y's, that are exactly r distance away from the center. So let's draw our unit circle. Okay, we call it unit circle because the radius is 1. So we'll mark 1 from the origin on the x and y axes. And then we'll create this decent looking circle. Now the radius is 1, which means I can also go this distance from the origin, and that line segment will also be equal with 1. So the next thing that we're going to do is going to inscribe a circle. So we'll start at the inscribe a triangle, start at the origin and draw a right triangle whose hypotenuse is exactly one of the radii of the circle. So this length right here is also 1. And like I said, this is a right triangle. Next, what we're going to do is we're going to put an angle inside and call it theta right here, the angle that is made with the origin at one of the vertices of the triangle. Then what we're going to do is label this point on the circle and call it some random xy. Well, what that means is that this distance here, that's x, and this distance here is y, right? Because in order to get to some point xy, let's say the point 2, 3, what do we have to do? We have to go from the origin over 2 units on the x-axis and up 3 units from the y-axis. Okay, and that's how we find a point. What we can do next is describe the trig functions for theta. So the ratio sine is given by the ratio of the sides opposite and hypotenuse, cosine, adjacent, and hypotenuse, tangent, opposite, and adjacent. And so if I'm asking you to find the sine of this particular theta, what I want is the opposite side ratio to the hypotenuse. Opposite the theta is the side y, and hypotenuse is 1. So what happens? We just get a y. So for the unit circle, the sine of theta is equal to the y-coordinate at the point where we are. As you might imagine then, cosine theta, which is going to be adjacent over hypotenuse, cosine of my angle is going to be given by adjacent side, which is x, and hypotenuse, which is 1, which also reduces to just simply x. So now we found that our point x comma y on the unit circle is actually representing the cosine theta and sine theta respectively. It's pretty neat. We might as well indulge and look at tangent. Tangent theta is the ratio of the opposite side, right, to the adjacent side. In this case, the opposite side is still y, opposite to theta, right, and the adjacent is x. Notice that this did not at all need to be over 1. And that actually makes tangent quite unique because it means that this ratio here is allowed to be greater than 1, since it does not rely on the hypotenuse here. Okay, so let's see how this will impact our unit circle. And for this video, we are assuming that you have looked at the special right triangles, our 30, 60, 90 right triangle, which has the following ratio of sides, and our 45, 45, 90 right triangle, which has a 1, 1, square root of 2. Those are our ratio sides there. This video assumes that you have looked at those two triangles. And the next thing that and it also assumes that you know how to convert degrees to radians and radians to degrees. Remember that the converting unit, if you're working with degrees, you will multiply by pi divided by 180, and if you're working with radians, you will multiply by 180 over pi in order to convert correctly. Okay, so let's assume that this is our unit circle. We're going to add a little dash here and here for the 15 degrees, which is not actually on the unit circle, and for our 75 degrees, also not on the unit circle, but it will help us. Okay, let's start with by filling in the quadrantal angles. So quadrantal means these. This angle here is going to be 0 degrees and 0 radians. Because this is the unit circle, that means that when I go from the center out here, I've gone exactly 1 unit, which is 1, and therefore the x value is 1. However, the y value is 0 because we didn't go up or down. This means that the cosine of 0 degrees equals 1, and that the sine of 0 degrees is equal with 0. So 15 degrees, we're not going to do the cosine and sine, since remember 15 did not come from one of my special right triangles, so we're not interested in that at the moment. So going by 15s, I get 30 degrees, 45 degrees, 60 degrees, 75, 90, and so on. We'll work with just the first quadrant for now, but this pattern does repeat, with the change being that the x's here are negative, y's are positive, x's here are negative, y's are negative. Here we have positive x's but negative y's. Okay? So let's continue. So 90 will be our next quadrantal angle. And for 90, we see that the radian measure is going to be pi divided by 2, treating pi as 180. The coordinates up here will be 0, 1, since we did not go left or right on x, but we did go up 1 unit. That means that the cosine of 90 is 0, and that the sine of 90 degrees is 1. Great. Now let's fill in the blanks. So these are going to come from our special right triangles. Let's do the radian measures first. So for 15 degrees, let's convert it. 15 degrees times pi by 180 degrees. What you do on your calculator is you say, okay, let's do 15 divided by 180, and then let's use the fraction to decimal button, decimal to fraction button, to simplify this. Doing that, you should get 1/12. And that way, 15 degrees is actually pi divided by 12. Again, we're not going to do the coordinates there. What we're going to do next is we're going to add 1/12 to each of our angles as we go around the circle. So we'll start with 1/12 plus 1/12, which gives us 2/12, which reduces to 1/6. So this is pi over 6 in the radians. 30 degrees is pi over 6. Now we can add another 12. That gives us 3/12, which reduces to 1/4. And so pi over 4 is the radian measure of the angle. It's 45 degrees. And so on. Add another 12. We get 4/12, which reduces to 1/3. Pi divided by 3. Add another 12. And we have 5/12, which doesn't reduce, but it does represent 75 degrees. We're not terribly interested in that. Add 1/12. We get 6/12. Wait a minute, 6/12 reduces. That becomes 1/2. And so we are back at our pi divided by 2. Now you want to keep this pattern going, again, keeping in mind that you have these increments of 15 or increments of pi by 12. And eventually you make it all around the circle. Let's do the coordinates. So for the coordinates, we're going to look back at our special right triangle, and we're going to say, what is the cosine and sine of 30 degrees? So cosine of 30 degrees, adjacent over hypotenuse. Adjacent side is going to be r square root 3. And hypotenuse is going to be r2. So the cosine of 30 degrees is rad 3 over 2. The sine of 30 degrees is opposite over hypotenuse, in this case, 1 divided by 2 again. We're going to pop that right into our circle. Cosine of 30 is going to be rad 3 over 2. Sine of 30 is going to be 1/2. Okay, back to our special right triangle. We want to know the 45s. Cosine of 45 and the sine of 45. The cosine of 45 is going to be adjacent over hypotenuse, which is 1 over radical 2. Now this can be written a different way as well. Let's do sine of 45 and then I'll show you. Opposite here is our 1, so we have 1 over rad 2 for our sine. And then what we can do with the 1 over rad 2 is we can rationalize it. We can multiply it by square root 2 over square root 2, and we get square root 2 over square root 4, but this simplifies into square root of 2 over simply 2. So you may see it as 1 over root 2, which is what we found from the special right triangle. Those are our cosine and sine of pi over 4 respectively, or 45 degrees, however you want to think about it. But also, this is equivalent to rad 2 over 2, rad 2 over 2. Now, because 30 and 60 are part of that same right triangle, their sine and cosine actually swap. If you don't believe me, check your special right triangle. And so if we change this right here to 60 degrees, now we are looking at the angle 60 instead of the 30. In this case, the adjacent side is now the 1. The hypotenuse is still 2, but now the opposite side is square root of 3. And so we have, for the cosine of 60, adjacent is 1, hypotenuse is 2. For the sine of 60, the opposite is rad 3, and the hypotenuse is 2. And we're going to fill that in accordingly. Now this is going to lead to a really cool property about cofunctions, but I won't give it all away in one video. 1/2 square root of 3 over 2. Okay? This pattern will repeat, like I said, and so this 30 degrees right here will match up with the 150 degrees here because they have the same reference angle. The only difference being that for 150 degrees, which is a different measure in radians also, the coordinates correspondingly are going to be negative and positive. So this will be negative rad 3 over 2 and positive 1/2. Okay? All right. If you have questions, reach out.